My topic is model based and case based reasoning. Before discussing about model based and case based reasoning, first we need to know about what is reasoning. Reasoning can be defined as a process of drawing logical conclusions from given information, and in artificial intelligence, reasoning is also the ability of a computer to make deduction based on the data and knowledge. And reasoning, that is one of the important key component of AI applications such as expert systems, natural language processing, machine learning, etc. Uh, Now I'm going to the topic case-based reasoning. Um, Case-based reasoning that involves solving new problems by recalling and adapting solutions from similar problems encountered in the past. Instead of relying on explicit models, case-based reasoning systems store and retrieve specific instances or cases along with their solution. That means it can be also defined as an automated reasoning and decision-making process for solving new problems through past experiences. And this is usually achieved by accumulating data to build a model of understanding of a problem that we are trying to solve. By storing the conditions of a problem and the actions it takes at that time, we are actually establishing a collection of rules that detect when in a given situation we have one or more actions to resolve it. And here the system then focused more on recognizing the similarity of new problem to the existing ones, but not only that, but also how to manage that collection of accumulated data. And the case-based reasoning is more like a human behavior, I mean human manner, in which we know that the human beings can conduct problem solving and also has correlation within the cognitive science. Next is the key characteristics of case-based reasoning. The first one is case storage. Actually, the system stores a library of previously solved cases, which include both the problem description and the corresponding solution. Second one is retrieval. When the system is facing with a new problem, it retrieve the most similar cases from the library. The third one is adaptation. Adaptation means the retrieved cases are adapted to fit the current problem. That means thereby allowing for the reuse of past solution in a more flexible manner. And the fourth one is learning. Learning means case-based reasoning systems that continuously learning and improving over time whenever a new case that are added to our library. Next is the example of case-based reasoning. Here is given an example for case-based reasoning. That means if the case-based reasoning is most widely used for medical diagnosis. Actually, in medical diagnosis, the system, I mean case-based reasoning system, that would store the past cases of patients with similar symptoms and their treatments and diagnosing details, all that. So whenever a new patient comes, then the system would retrieve and adapt relevant cases to suggest diagnosis and treatment plan. And another important real life example of case based reasoning is that if you are entering in a coffee shop, we know that how to get inside the building by just opening the door. And that means we don't have any question it given you, because we are learning that thing early in our age. That means how to open that door and how to enter in that coffee shop, etc. And that means here we are just opening the door and go in and order our coffee. And here there is no matter if the door that looks like the same that we seen before, or not. That means we are just opening the door. That means we know that how to open that door. We understand how to open that door. It's a door, and how to open that door, or how that door will work. And this case-based reasoning is also used in gaming platforms. I mean, video games. For an example, if we consider that we have an enemy moving towards as in a gaming platform, so here we will often jump over or onto it. Here we are building an understanding of when jumping on an enemy proves the best outcome versus jumping over it. So when we meet similar situation again in the future, we know that how to tackle it. And so games are designed such a way in such manner that players to memorize the patterns of behavior that will yield a positive outcome and make them repeat those patterns throughout the game actually. So if this is not properly implemented or established, then you know that the game that become more confusing and more complex for us. Next I'm going to the topic CBR components, and that means there are so many components in CBR system. The first one is case base. Case base actually function as a repository of prior cases, and here the case that contain general description of all the problems. And next one is retriever. Whenever a new problem that is entered into the case-based system, the retriever is actually deciding or it decides on the future similar to the stored cases, and retrieval is done by using the features of new cases as indexed into the case base. Next one is adapter, and actually the adapter that examines the difference between these cases and the current problem. And next one is refiner. Refiner critiques the adapted solution against the prior outcomes. That means one way to do is to compare it with similar solution of prior cases. If okay, next one is executor. Executor means once a solution is critiqued, the executor applies the refined solution to the current problem. And evaluator means if the results are expected, no further analysis is made, and the cases and its solution is stored for use for future use actually, and if not, the solution is then repaired. And next topic is CBR workflow. That's important. Actually, when we are discussing about case-based reasoning, the CBR is constructed or structured as a four-step process. The first one is retrieval, second one is reuse, third one is revision, and fourth one is retention. So retrieval means the process of finding a case that is similar to our current situation. Reuse means when we retrieve a case and propose it as a valid action to apply in our current state. And revision means that is when we evaluate through a series of metrics or simulations how well the proposed action will perform and whether it is practical to apply it in a particular case that we are in. And retention that is usually applied after successful execution by storing the result of this experience in the memory, and this is useful when we are revised the proposed solution given it now clearly an individual case. Next is the application areas of case-based reasoning. The first one is healthcare area. I mean, I'm already discussed this in the previous slide. That means it is mainly used in the medical diagnosis. Used for medical diagnosis. And the second one is customer support. That means for resolving issues by recalling similar past incidents. And third one is law, legal case analysis, and precedence-based decision making. There are so many applications also exist in the case of case-based reasoning. Only a few of them are given here. Next, there are so many advantages for case-based reasoning. The first important advantage is its flexibility. That means it is adaptable to various problem domain and does not rely on the predefined models. And the second one is learning and improvement. That means the system actually that improves over and over, over time, whenever a new case that comes. That means it is continuously learning from the experience. And at the same time, it has so many disadvantages. The first disadvantage is computational complexity. That means as the size of the case base grows, the computational complexity of the retrieval process will also increases. The second one is limited generalization. Limited generalization means the CBR actually that relies heavily on past cases to solve new problems. So this will become a limitation when facing completely novel situations where there are no similar past cases. So in such cases, the system will definitely struggle to generalize and provide effective solution to that case. Next is difficulty in representing knowledge. That means representing knowledge that is in a form that is suitable for case-based reasoning is always challenging task for us. And next one is difficulty in handling dynamic environment. This is one of the most important disadvantage of case-based reasoning. That means CBR system may face lots of challenges in adapting to dynamic environments, because we know that where the relationships between features and solution that will changes over time, and so adapting to new information and evolving problem scenarios can be complex task for case-based reasoning. Next, I'm going to the topic model-based reasoning. Model-based reasoning that mainly involves the creation and utilization of explicit, often symbolic models of a system or problem domain. And these models represent the structure, behavior, and relationship within the domain. The reasoning process involves manipulating these models to draw conclusions and make predictions or solve the problems. And here is a figure of model-based reasoning. And that means the model-based reasoning can be also referred to the reasoning method that is used by expert systems, that is based on the models of the physical world. In this approach, the main focus of the application development is the model development actually. And at a runtime, the engine then combine the model knowledge with the observed data to draw conclusions such as diagnosis and predictions. Next, the key characteristics of model-based reasoning. The first one is explicit models. That means model-based reasoning that relies on the construction of explicit models that represent knowledge about the system. And the second one is symbolic representation. The models are often represented symbolically using formalisms such as logic, mathematical equation, etc. The third one is inference and deduction. Reasoning in model-based system that involves making inferences and deductions based on the rules and relationships encoded in the models. Last one is problem solving. That means these systems are commonly used for problem solving and decision making in dynamic and complex environments. Next, here is an example for model-based reasoning. That means if the model-based reasoning systems are used for diagnosing faults in a mechanical system, then the model definitely that include information about the relationship between various components and their functions, possible faults that can occur in the system. So the system then use this model to deduce the most likely cause of the observed problem. Next is the application areas of model-based reasoning. The first one is autonomous vehicles. Actually, it is widely used in autonomous vehicles for navigation and control systems. The next one is natural language processing, and NLP is one of the evolving area in the recent years. Next important application area is game playing. Game playing means the model based, especially in chess. That means the model based reasoning is employed in creating AI agents for playing games like chess and chess. Next one is medical diagnosis. I'm already discussed about it. And that means it can be used to build models of human body and its various systems. So later these models can definitely help in diagnosing medical condition based on the observed symptoms and test results. And the last most important application area is in robotics. That means it is very essential, model based reasoning, that is very essential for robotic systems to plan and execute tasks very efficiently. And there are so many application areas for model based reasoning. A few of them are given here. Next is the advantages of model based reasoning. The first one is systematic problem solving. That means how the model based reasoning provides a systematic approach to the problem solving. And second one is efficiency. That means it discusses how explicit models streamline the decision making process. And another one is adaptability. When we are discussing about adaptability, first we need to know, we need to discuss about flexibility. That means model can be adapted or modified based on the evolving nature of the problem. And next one is versatility. That means applicability to various domains and problem types. And at the same time, it has so many disadvantages. The first one is model complexity. Model complexity means building accurate models. That is always a challenging task, especially in such a case that for complex systems. Next one is computational complexity. That means in model based reasoning, that will definitely involves computations based on the model, and these computations can be computationally expensive in most of the times. Next is model maintenance. That is one of the major disadvantage. That means the model that continuously need to be updated and maintained over time to reflect the changes in the system or environment. This is not possible in most of the times actually. And next is the difficulty in representing intuition. I mean, some aspects of human reasoning, common sense may be challenging to represent accurately in case of models. So capturing these aspects is crucial for a AI system to exhibit human-like reasoning ability. That is why I'm saying that there is always a difficulty in representing intuitions. So this is all about my topic. Thank you.